First of all, thank you so much to Adam and the team for hosting us here in KL for this inaugural Future Digital Twin and AI. It's an honor to be here. Let's see if we can get my slides on the screen. I see slides, I don't see mine. I'm going to keep this slide, so not too much slides. Oh, we're waiting. It's a countdown timer. Then maybe we can go back to this. We talked about the shopping lists and my wife and everything, right? It is quite the topic to anchor some of this on. But let's go to automation, because we'll touch on some of the same points actually when I'm talking about this. So my name is Øystein Hole. I'm the Chief Product Officer of Kongsberg Digital. And I'll give you just a brief look into what we're thinking about how is it that we will actually make some tangible steps towards intelligent automation. Everybody knows, and as our esteemed guest Sarah from Petronas told us this morning, we know some of how the future looks like. We know that we have higher energy demands. We know that we have basically higher demands on operational efficiency, safety, the types of energy that we produce, and so on. But first, let me just start you off with a small glimpse of what we're doing in the space of industrial work.
Introducing the all-new industrial work surface from Kongsberg Digital. Industrial intelligence at your fingertips. At the center of it all, your surface. One source of truth, one clear line of sight. From the big picture down to every detail. Where insight meets action. And every workflow is fully connected. Powered by agentic AI, supporting decisions, learning from your workflows, and making data work for you. Empower connected workers with everything they need. Context, collaboration, and control in real time. The all-new industrial work surface of Kongsberg Digital.
So, what does this future look like? Right? So one of the examples that I will keep coming back to today is that if we look at actual autonomy of assets in the future, we're also looking at mechanical operations, for example. We're looking at robotics, and we're looking at, let's call it the more seamless electronic operations of this. Now, we briefly touched on it here, right? It's a little bit of the same discussion as what's a digital twin, it's what's an asset. And we also believe that it's crucial for our understanding of how we will be able to automate things in the future to bring in much more context about the operating context of the asset. So you can imagine that if you want to have a fully autonomous asset, it still has quite a lot of context it needs to deal with. It could be the market, right? A critical component to why do you want to produce with the envelope and with the production targets that you have. It could be the weather, the temperature. It could be as far as geopolitical situations, so you can predict into logistics, which some of us has gotten a little preview of this week. But to get there, we need different types of intelligence in our systems. And as we also addressed a little bit here in this panel that we had, the fundamental element of this is to have more intelligence embedded into our data. And unless we're able to come together as an ecosystem to fuel, let's call it an industrial knowledge graph, where you have all of these implicit relationships, where you have all the quality of the data, you simply don't have enough data to make good decisions. Then you end up back in this situation where you have to rely on humans, you have to rely on phone calls, discussions, workshops to figure out why do you even need to do something. And of course, we see that by combining the technology we already have today, right? We have agentic AI, we have contextualization engines, we have data platforms, we have ecosystem integrations and connections. we can leverage that to work towards this industrial knowledge graph. And of course, that allows us to train our people, because it does mean that if we come to this, if you come to the system where the table is basically already set for you and all the relationships are there for you to explore, you don't have to go to 10 different systems to learn about an asset. You can understand the operational context and everything from a singular interface, for example. That translates into the foundations we need to train even LLMs, right? So it's one thing to train them on the collective works of Shakespeare, but it's a completely different thing when we can look a bit into the future and start to train models on the structural relationships that we expect to find in industrial data. And of course, today we can do this to somewhat local scales, regional scales, which large companies can do this internally. But of course, we need to get this more fundamentally embedded into how we build large models. But data intelligence is only one of the types of intelligence that we need to bring to AI in the future if it's going to support autonomy. Spatial intelligence, it's one of the things that we take most for granted after a certain age, when we stop bumping into tables on our way around the living room, for example. We grow up and we spend most of our formative years just learning to deal with the spatial reality that we need to deal with. And the interesting thing is that we train in real life, right? But we don't really have that luxury. So if you think about robots or AI as babies, it's not like we can let loose an army of babies to run around on our real assets and bump their heads and turn the wrong levers all the time until they've trained this intuition into their minds. Which brings us a little bit back into this industrial digital twin sphere, where yes, we need the spatial digital twins to exist, but we need them with more intelligence than what we have today. Because what we have today is random data that was built for different purposes. So we have CAD models, some of them modeled to support engineering, some of them modeled to support the actual construction, some of them modeled just as an afterthought to make a PowerPoint slide presentation for executive management. There's so many different reasons that this has been done, but what it hasn't been done for is to have data that is good enough for us to, for example, train models. So, of course, this is an area where we already know that this is not solved by us alone, right? We need to work together with the EPCs, we need to work together with tech hyperscaler partners like NVIDIA with their Omniverse solution, which is what you see here on screen integrated into our system, so that we can leverage the collective intelligence of the ecosystem to have assets that are ready to be simulated well enough in the physical realm. It means materials, properties, navigation. It means if you bump into a wall, what kind of wall is it? Will it actually hurt the wall or the robot if they bump together? And of course, environment, lighting, and so on. Bonus is that it gives you some quite good visuals on top. Physical intelligence is a lot more than the distance between two steel beams, though, right? It's about temperature, pressure, flow, and how all of this is orchestrated together, or how the topology of this shapes the operations of a given asset. And there's a lot of types of abstractions and technologies that we built around this over the last decades. We in Kongsberg Digital have process simulation, something that we've done for years, right? Being able to simulate a full asset in its current state, in a training scenario, or looking into the future by basically doing all the thermodynamics and all the flow situations that you need to converge, basically, to know what's going on in the asset. Because if we want to train AI to understand what's going to happen if it affects a change on an asset, we can't ad hoc start to try to make tables of how all of this is going to work. We need systems that it can train on. So it can do a change, observe the effects, and then go back and repeat this ad nauseum until it has a wide enough knowledge base that it knows what's going to happen in real life. All of this training, though, brings us back to one of these ultimate convergences that we see, because even doing model training at such a scale that you would need to train ML models to understand all the scenarios of an asset would be an enormous amount of manual work today unless we apply AI to do the training for us. So this is also a bit of thinking we need to do to make sure that we can also use agents to orchestrate the training itself and thereby be able to do at a much, much larger scale than what we've done up until now. And of course, what we get from this is then the ultimate training data and the ultimate scenarios that we can use to train robots that are already now, from our previous point, trained to navigate the physical world in terms of spatial properties, but it also needs to navigate the physical world in terms of what happens to the pressure here if I were to turn this valve, or what happens to the efficiency of our heat exchangers if the temperature drops to a certain level. And ultimately, we need to ensure that also some of the deeper whys and some of the more high-level processes is something that these assets and these robots or agents and humans can be trained on. Because when it comes to these questions about, well, like, why do we do maintenance at all, right? That's not a universally given constant that's just embedded into an AI if you don't explain it to it in a good way. So whether it's from regulations, whether it's for asset management procedures, or whether it's from looking at the cause of effect of how to operate something, it's extremely important for us to be able to also articulate the processes that we run by in such a way that that can be trained on by agents, robots, and humans alike. So what we need to do, it's quite simple actually. It's about the ecosystem, because there's no one player that's going to get all of these things right in one go. And it's just an enormous field of opportunity because of that energy demand that was mentioned here is going to be ever increasing. The demand for clean, stable, reliable energy will just go up in every part of the world over time. And to meet this, we need a lot of the companies that you, for example, see here today, or in any other similar event around the world, to come together to solve it. A lot of it's really boring basic work. It's about standards, but the standards aren't there yet at all, right? So we had the questionnaire about common data models, for example. There are standards, plural, but no one really agrees on what the right path is onwards there. So for the ecosystem to take the next steps to figure out what does it take for us to actually embed this, of course, that flows into the next one to make sure that agentic AI is being applied with the right principles on top of these standards so that it can be done in a reliable, secure, and trusted way. Semantic and physics modeling, if we don't do that and we just throw, let's call it autonomous agents into the real world to do all of their training, they won't get the textbook knowledge. Right? So it's the same problems that we see with some of our efforts around training AI models today, where you say that, oh, we'll run out of data. because we're just trying to train on what's readily available in the real world. If we did the same equivalent with humans, we would say that you just train on whatever is around you. But we realized that a long time ago, and we started to develop, let's call it authoritative texts that could describe the world to us, could describe the processes in a better way. And this also needs to be embedded into how we think about AI. And ultimately, all of this needs to be integrated together, right? So companies have to be open to exchange data, open to have their agents, their training algorithms collaborate together for us to be able to run and automate all of this in one singular fashion. And that's how we will be shaping the future of work. Thank you.